Welcome back. In today's HackerRank C challenge, we are working with pointers in C. Pointers are one of the most powerful features of the C language because they let you directly work with memory. That means a function can modify variables it doesn't own, something you can't easily do in many other languages. Now let's explain pointers simply. A pointer is just a variable that stores a memory address. Now, to better appreciate this, I'm going to give you a brief breakdown of what this whole idea of memory address has to do with this. So now, in your computer, right, there's RAM. Anytime you run a program, like your code, anytime you run your code is loaded into the RAM, what we call memory, simply put. So your code is loaded into memory. Now, when your code is loaded into memory, each section of your code, each line of your code, which will be executed, has a memory address. And each variable you create also has a memory address. Every function you create has a memory address. And the memory address is simply the location where these things are. So when you create a variable, that variable has a certain memory address, and you can access the variable if you know the address of that variable. The address you can think of as the location of that variable. So once you have the location, you can go in there and do anything you want to do with the value that is stored there. Okay, and that is what a pointer is. A pointer is simply a variable which knows the address of something. It could be a variable, another variable, it could be a function, okay? It could be anything. But a pointer is simply something, a variable, that holds the address of another variable or function. It simply points to that variable, hence the name pointer. Now, to get the memory address of a variable, you see the ampersand symbol. You use that. Okay, so you remember in the scanf function, when I was talking about using scanf, I made sure we used ampersand in front of the name of the variable because ampersand is known as the address of operator. And when you use ampersand in front of a variable name, what you get is the address of that variable, meaning the location of that variable. Now, apart from that too, one thing you should also know is that to access or change the value stored at that address, use the asterisk operator. So I'm very sorry, let me write those here. So we have the ampersand, okay? Ampersand is the address of the operator and it gives you the address of the variable, okay? And then asterisk is what we call the dereference operator. When you use asterisk, it allows you to go to that location and change the value that is being stored there. That is what asterisk does. Now, let me demonstrate to you pointers and these two operators in action before we solve the challenge. So, this is the online compiler. I'm just going to create a variable. And I'm going to store the value 25 in it. Now, I'm going to print to you the address of this variable. The format specifier to print addresses is %p. So address of num. And now let's run this. So you can see clearly that we have an address in hex format, hex 7FFF065CE49C. This is the address hexadecimal. Okay, now that is using the ampersand. So now if I want to create a pointer, an integer pointer, this is what I'll do. Int with asterisk That's the syntax. The syntax, sorry, let me write the syntax for creating a pointer down here. So the syntax is data type, okay, asterisk, the name of pointer. This way. So you bring your data type, you always bring asterisk once it's a pointer. And then you bring the name of the pointer. Okay. So in this case, you are going to have int, since I want my pointer to point to an integer variable. So I need to make sure it's an integer pointer. Okay. And then the name of the pointer. So I'll call it pointer to num. Okay. And I'll make it point to num. So if I want this variable to point to num, then I must store the address of num within it. So we are going to have it equal to the address of num. Okay. So now if I print that, and we run it, we should get the same thing. So you see, the same value here is the same value we have here. That tells us that effectively ptr to num is pointing to num. Now what can I do with this? So I'm going to use the reference operator now. I'm going to demonstrate the reference to you. We are going to change the value that is being stored within num variable to -5. But we will not change this. Ordinarily, if I wanted to change to -5, all I have to do is come here and type -5, right? And then it will be storing -5. And let me also write another printf statement to print the value stored in num so that we can track this effectively. So it's storing -5, right? At first it was storing 25. So now if I wanted to change it, all I had to do was come here and change it. Or maybe I got to a point in my code where I need to use a pointer. I just want to demonstrate to you how we can use pointers to make these changes and prove to you the potency of pointers. So now we are going to use this ptr to num to change this 25 to -5. And this is how we are going to do it. We're going to use the dereference operator. So we'll dereference ptr to num. And that gives us access to the value. And then we'll just change it to -5. Because we know ptr is pointing to num, once we dereference it, we are actually entering the location where the num variable has its value and we are changing it. So once I do this, it should change. Now, if I try to print the value stored in num now after this code, it should be -5. So let me do value stored in num after pointer change. Okay. Now let's run this. So you can see it changed to -5. Now I didn't touch num. What I touched was ptr to num, but it ended up changing num. Why? Because ptr to num is pointing to num. So this is the concept of pointers in simple terms. Okay, I wanted to give a brief intro before we solve the project, the challenge. So this is it. Now let's go back to the challenge. In this challenge, we need to complete a function called updates. It's supposed to set the value of a to the sum of the two numbers, and it should set the value of b to the absolute difference of the two numbers. And notice that it is taking in pointers. So it's taking a pointer to A and a pointer to B. So meaning that we'll have direct access to these variables. And what are we supposed to do? We are supposed to store in A the sum of the two numbers and store in B the absolute difference of the two numbers. So that's what we are going to be doing. And to make this very easy, what I am going to do is to start writing this function. To first break down to you our procedure, our thinking process. So first, what we want to do is we are trying to store A plus B in A and store absolute of A minus B in B. Now to do that, since we'll be changing the value in A, we should create a temporary variable to store the A, okay, the actual value of A, and then use that temporary variable to work as A so that we can work without causing any confusion. So this is what I'm going to do. First, create a temporary variable for A. So we are going to have int temp is equal to. Now, we want you to store the value in A. So I'm going to say int temp is equal to asterisk A, because the A that is being passed to the update function is a pointer, okay, not a value, it's pointer. So we'll have this. So now temp is holding the value that's stored in the A variable. Now we can calculate the sum. This is the sum. Okay. Now we are going to store the sum in A. So that will be asterisk A is equal to sum, and that changes the value. Now we are going to calculate the absolute difference. What we'll do is we'll first find the difference and then find the absolute. Now you see we can no longer use asterisk A because asterisk A stores the sum. That's the reason we created the temp variable. You see? So now the difference will be equal to 10. Right? Minus asterisk B. You could have decided to go by a different approach. Calculate the sum, calculate the difference before storing it in A and B. That would have also worked. But I'm using this approach. So int difference is equal to temp minus asterisk B. Now we need to find the absolute. Okay. So what I'm going to do is we'll create an absolute function called absolute. So actually I wanted us to create it together, but the truth is there's actually a function called apps which does that. So let's just use that, and then as your assignment, learn how to create the absolute function yourself. It's quite simple. It's very simple. So we'll have to import another header file known as math.h. before we'll be able to use the apps. Sorry, we rather need stdlib.h. The math.h doesn't contain, it's rather stdlib, standard library. So this calculates the absolute difference and then we'll store it in B. That's all. Since it's a void function, we return nothing. So what's this doing? It's calculating the sum of A and B, storing it in A, calculating the difference and storing it in B, directly in the A and B variables that were created here. And this is possible because we passed pointers. So you can see here, sorry I didn't go through this code, but let's go through. We first create A and B, and then we create a pointer to A and a pointer to B. Okay, and then we pass those pointers to the update function. Then the update function will access, since it points to A and B, it will be able to access these two variables here, so that when we call update and then we print here, we will get the updated values of A and B. So let's run this code. It works. Let's test with other cases. It works as well. So that's it. This is how pointers work in C. And you've learned how to pass memory addresses into functions and how to modify variables in place. If you still don't get it, I'd advise you to re-watch this video again to better grasp the concepts. If there are any questions, leave them in the comment section down below, and I'll try as best as possible, as much as possible, to answer all your questions and provide you with more useful resources to understand various concepts in programming and to make your programming journey smooth and easy. The link is in the description below to practice the challenge on your own.